Okay, so we have an artery, diameter is 10 millimeters. In the center, well, at distance r from the center, you have a decreasing speed. As r goes from 0 to 5 millimeters, that's from the center to the artery wall, in fact, the speed decreases from 8 millimeters per second to 0. And that's, of course, in millimeters per second. And that's, again, as r goes from 0 to 5 millimeters. So there's a lot of information in this problem, but this is one thing you can grab onto, because we're talking about something that happens between r equals 2 millimeters and r equals 3 millimeters. Well, we're going to want to get the velocity at this point and this point. Now, that can be done by simple proportionality, but you know, maybe having a little bit of difficulty doing that. So the purpose of this problem is not to draw the trapezoids that I'm going to draw, or the trapezoids that I'm going to draw to determine those speeds, but I'm going to use trapezoids to do that. This is a further illustration of trapezoids and their interpretation, because that's what we're really trying to get into, because that's how you learn to interpret, or that's how, at least in this course, we're going to learn to interpret derivatives and integrals. Okay, so the trapezoid goes from 8 millimeters per second down to 0 millimeters per second, which is going to give us a really short side here, as r goes from 0 to 5 millimeters, right? So here we got 0 millimeters, here we've got 5 millimeters. So here's our trapezoid. Its width is 5 millimeters. Its rise is what?
8.
Well, if the 5 millimeters goes from here to here, then any movement we make on this trapezoid has to be from left to right, or from the point, you know, from this position to this position, okay? Now at this position, there's our 8 millimeters per second. If we go from here to here, our rise is negative 8 millimeters per second. So the run is 5 millimeters, right? So slope equals negative 8 millimeters per second divided by 5 millimeters, which equals negative 8 what? Well, if you divide millimeters per second by millimeters,
In seconds.
you don't get seconds. Yeah, I know what you want to do. You want to cancel out the millimeters. You don't cancel out that division sign. Okay? And we don't cancel in this course anyhow. But at least I won't cancel. If you do it right, and I believe you probably will, you do it, but that's a total misuse of cancellation, which is why I usually never talk about cancellation. It's negative 8 millimeters over seconds multiplied by reciprocal millimeters, right? Division by millimeters is the same as multiplication by reciprocal millimeters. Well, that equals negative 8. Now we can do 1 over second times millimeters over millimeters, right? And of course, millimeters over millimeters is just like 1, it's like unity. So that's just going to leave you reciprocal seconds, right? And we write that as negative 8 seconds to the negative 1. Because anything to the negative 1 is the reciprocal of that thing, right? Meaning of negative exponents. So now we have a slope that we can label here. Negative 8 reciprocal seconds. Okay? Now, what we want to know, if the speed goes linearly from this to this, then, and this is officially just a trapezoidal approximation, right? But if we know the speed is linear, well, that means that this is actually the way the speed goes, okay? Now, in an artery, the speed really won't go linearly from the maximum down to the minimum, okay? But it's not a bad approximation to get an idea of how much blood is flowing in this artery, okay? The rate at which blood is being transported. So, what we want to then say is, well, okay, there's 0 millimeters, there's 5 millimeters, so we've got 2 millimeters here and 3 millimeters here, right? So, if we could determine the length of this and the length of this, we would have the speeds at those points, right? Okay. Now, other options, we could just set a linear function. This is a y equals mx plus b function. If y is your speed and x is your position between the center, you know, the value of r, okay? Or if you want a y equals mr plus b, if you want to keep r for the variable, which you probably would, okay? So that's one way of finding this. You can set up your linear function and evaluate it for r equals 2 and r equals 3 millimeters, right? So hopefully you know how to do that or can figure it out, and I recommend that you do. But I'm going to do it with trapezoids, okay? So another way to do it, of course, is with similar triangles, right? This triangle here is similar to the big triangle, but its base is only 3 millimeters, so it's going to be 3/5 the dimensions of this triangle, right? Which means that this is going to be 3/5 of 8, 24/5, 4.2.
So you would just multiply the 8 by 3/5, or?
Well, yeah, but I mean, you could do it with similar triangles. I'm not going to do that,
Okay.
but 3/5 of 8, okay? And it's actually 4.8, not 4.2, but okay. And then you have this one here. Well, this distance is only 2 millimeters, whereas this is 5. So this triangle has dimensions 2/5 as great as this one, right? And 2/5 of 8 is 16/5 or 3.1. 3.2. Having a great day here. Okay. So I think we're going to get 4.8 millimeters per second and 3.2 millimeters per second. Now, in order to do applied problems, you have to be able to do this, you know, pre-calculus level reasoning, okay? And I believe you can one way or another. But those are two alternatives for figuring out what those speeds are. Model this with a linear function. Model velocity versus r as a linear function. Take this diagram and use similar triangles, totally valid. But to illustrate trapezoids, I'm going to go ahead and set up, well, I've got a trapezoid right here. I've also got one here, okay? Or I could do a trapezoid from here to here. Or I could do the trapezoids here that have zeros over here, right? Well, I'm going to, just for illustration purposes, it's probably not the easiest way to get it, and often we would take the easiest way. But for insight into what these things tell us, I'm going to say, okay, now we got 8 millimeters per second here, and we've got a trapezoid of width 2 millimeters. Okay? So, what do we know? What else do we know about the trapezoid? Well, we know the slope, don't we? Because this is a straight line, and this is the same straight line, presumably, implicitly. Didn't really state that. So, again, we have our -8 reciprocal seconds. So how do we analyze a trapezoid? Well, first of all, we list all the aspects of a trapezoid. Again, I don't know if you had a chance to see the videos, just 2 days ago. But what are the aspects of a trapezoid? Well, we have the left altitude and so forth. I'm going to stop the video here and list these things, okay? No need to take time on the video to watch me write down stuff.